Okay. Good evening, everyone. My name is Chandan Kumar Gupta. I am a research scholar in Department of Mathematics, IIT Patna. I am your NPTEL PMRF TA for the course Probability and Statistics. This course is offered by Professor Somesh Kumar. He is a professor in IIT Kharagpur. Okay. This is the 7th week of the 12th week course. And in this week, we will probably discuss about the bivariate distributions like uniform, beta, gamma, and then it is about to addition properties of different distributions, chi-square distributions, central limit theorems, and there are some more topics like, let me check, order statistics and transformation of random variables. Okay, hope you people have already watched the videos. So we will just take a snapshot of the some of the topics and then try to solve numericals. Okay, anyone have any doubt, then please ask, or if you have doubts regarding the previous lectures, you may ask on like YouTube section, or you may mail me. I have already, perhaps you people have already mailed my mail, so you may directly mail me. I will definitely respond. Okay, then we will start like additive properties. Sorry. Just give me a minute. Okay, additive property, that means like we have different kind of distribution. Okay, and all distribution like for example, suppose x1 follows like binomial n1 and p. Okay, x2 follows binomial n2p. Similarly, like xk follows binomial skp. We have different random variables and both follows the same distribution binomial with different n parameter and the same p parameter. Okay, in this case, in this scenarios, like the summation of xi, which may already sk, which is from summation I from 1 to k xi, it is also follows binomial distribution with parameter summation ni and then p. Okay, so when we have some conditions, then we may find the sum or product of the distribution of random variables. Okay, so it is additive property. Then we are discussing about the sums of different random variables. It may follow some particular distribution, or it may not follow some particular distribution. Okay, our aim is to check. Okay, like in the same case, like Poisson distribution, suppose xi follows Poisson lambda I. Okay, for I equal to 1 to up to k. Then again, it follows this. Okay, that means binomial distribution or Poisson distribution follows the additive property or holds the additive property. Okay, and we have geometric distribution as well. Like x1 up to xa follows geometric p. Okay, then sk, which is summation of xi follows. Can anyone tell me which distribution? Because geometry distribution has only one parameter. So is it geometric NP or something else? These all already discussed in the lectures actually. Okay. So this is actually negative binomial distribution with parameter P and number of successes K. Just think, geometric distribution is a particular case of negative binomial distribution. Okay, when we are dealing with only one success, then the negative binomial distribution tends to geometric distribution. Okay. Similarly, okay, like suppose up to xk. Okay, these are independent and follows negative binomial distribution. Okay, with parameter like ri and p. Okay, r1 p, r2 p. Okay, then again it is also follows negative binomial distribution with parameters summation of ri and p. Okay, in a similar way, like if xi follow exponential lambda I. Okay, not exponential lambda, it's exponential lambda actually. Xi follows exponential lambda. Then sk, which is summation of xi, it follows gamma lambda, and there if I equal to 1 to up to k, then that is k lambda. Okay, so these are some of the property here. Exponential converted into like a gamma distribution, here geometric in negative binomial, and so on. Like again, like xi follows gamma. Suppose ri lambda, then sk, which is summation over xi, it follows again gamma, but the parameter is like lambda and summation of ri. Okay, that is xi follows gamma, then summation xi follows gamma. Xi follows lambda, then summation xi follows gamma. In the similar manner, there are some distribution which does not hold this additive property, but most of them may hold if there is a condition like independence. Here all xi's are independent at least, so this condition holds. Okay. Okay, then like linearity property. Linearity property of normal distribution. Okay, so suppose like x1 follows normal mu1 sigma 1 square, x2 follows normal mu2 sigma 2 square. In a similar manner, like xk follows normal mu k sigma k square. Okay, then y. We will define a random variable, a new random variable y, which is a linear combination of x. That is ai xi plus bi. Okay, this also follows normal distribution. We have already discussed about it. Okay, so what is the parameters? So the parameter is like okay, it follows normal a mu plus b. Okay, here actually let me write like something. If x follows normal mu sigma square, then y equal to ax plus b follows normal a mu plus b, and sorry, A square sigma square. Okay, so we need to find out like summation of yi. This this follows. This follows actually like it's normal summation of this, that is ai mu I plus pi, and summation of ai square and sigma I square. So normal distribution also follows additive property with the linearity property as well. Okay. Okay. Then here like okay. Also we have some property like like variance of summation of xi. Suppose we have variance of x1, variance of x2 up to variance of xi. It is in general. Okay. It is in general. Variance of summation of xi, I from suppose 1 to n. In that case, it is summation of variance of xi, okay, plus twice of covariance of xi, xj, here I is less than j or I is greater than j. You may take any one condition. Okay, so this is the variance. If the xi's are independent, then these terms comes out to be 0. In that case, variance of summation of xi equal to summation of variance of xi. Okay. In the similar manner, like covariance can be calculated. Covariance of like summation xi yj. Suppose I from 1 to m, j from 1 to n. Okay. So this can be calculated as covariance of like xi yj. I from 1 to m and j from 1 to n. So if we have individual variance or individual covariance, then we can evaluate the covariance of the summation of those variables with the help of those given. Okay. So now like bivariate distribution. Okay. So you people may know about the generalization of binomial distribution, which is multinomial distribution. Then different kinds of multinomial distribution you have like trinomial distribution. We have example. Okay. Then bivariate beta distribution, bivariate gamma distribution, bivariate uniform distribution. Okay, these are already discussed. Let me write bivariate gamma distribution, not gamma. I just wanted to discuss about bivariate uniform. Okay, here like it is a discrete distribution actually. Okay, like this is twice of k plus 1. Here like x2 equal to 1 to up to x1 and x1 equal to like 1 to up to, suppose we have taken k distribution, then up to k, where k is what? Any positive quantity, any positive number. Okay, here in bivariate uniform distribution, actually the correlation coefficient between these two, x1 and x2, can anyone tell me what is this? Am I audible now? It is 1 by 2 actually. Okay, in bivariate uniform distribution, the correlation coefficient between the variables is half. Okay, that's why I am discussing. Okay, then we have a very topic like transformations of random variables. Okay, so suppose we have a given distribution like x follows some distribution, and we need to calculate y equal to, which is a not f of suppose g of x we can write, and we need to calculate the PDF and the different statistical characteristics of y, which is a function of x, like suppose 2x plus 3 or something else. Okay, so we may directly use the concept of this transformation of random variable and we calculate the PDF of y. Okay, for this we have some conditions or some assumptions. Okay, like we can write like this for univariate. Actually, we can write like this, like which is equal to f of x dx upon dy, or in case of bivariate, we can write like uv, which is a function of xy. So it can be written as like fxy and Jacobian of this, where Jacobian can be evaluated as like del x upon del u, del x upon del v, del y upon del u, and del y upon del v. Okay, we have always considered the positive quantity. Okay, and the assumptions like it exists. Okay, that means we have given the u of like f1 xy and v equal to like f2 of xy in such a way that these two are invertible function. Like we can write function of like this and y equal to okay. So this happens. Okay, we will also like try to solve some questions on this topic. Okay, now check. Okay, like sampling distribution. Sampling distribution actually it is it is a distribution of statistic. Okay, the probability distribution of statistic is called the sampling distribution. Okay, and like statistic is something like which is a function of sample values like sample mean, sample variance, sample median, sample mode, or anything which is evaluated with the help of sample. That is called statistic. A function of sample values is called statistic, and the distribution of those statistics is called sampling distribution. Like we may discuss about t distribution, f, chi-square. These are the small sampling distributions, or we may directly say sampling distribution, which we are going to discuss. And in this week lecture, we are mainly discuss about the chi-square distribution. Okay. So chi-square distribution is like suppose like the PDF of this, suppose W, we have W as a chi-square variate. So the PDF of this is like this, n by 2, gamma n by 2, and e to the power minus w by 2, and w to the power n by 2 minus 1. Okay, here w is greater than 0 and n is greater than 0. Here n is called the degree of freedom for the chi-square distribution or chi-square variate. Okay, and if you may recall this, it is a particular case of gamma distribution. Okay, a special case of gamma distribution with parameter. Actually its parameter is like n by 2 and 1 by 2. Okay, then the expected value is like this. Expected value of w is like n, which is equal to its degree of freedom. Variance is like twice of n, and suppose we may calculate the third order moment, central moment, which is equal to about 8n, and the fourth order moment is 12 times of n plus 4. If you may solve, you may find out like it is a positively skewed distribution. Okay, and for a small value, it is a leptocortical. Okay, if we consider like if we increase the value of n, then it follows a normal distribution. Okay, and the last thing is like central limit theorem. Can anyone confirm I am audible or not?
Yes, sir.
Okay, thank you, thank you. Okay, now central limit theorem. Like the statement for this theorem is like that. Like suppose let x1, x2 up to xn, large number of n, okay, be a sequence of IID random variables, okay, with given mean mu and variance sigma square. Okay, suppose we have x1, x2, and xn. These are IID random variables with mean equal to mu and sigma square is the variance. Okay, and the sample mean is defined as like this: 1 by n summation of xi. Okay, then the limiting value, like the standardized variate, like x bar minus of mu and divided by sigma by root n. The variable minus its mean and divided by its standard deviation. This is the standardized variate. Okay, so any variate or variable can be standardized with the this like with this use. Okay, so this actually approximately follows normal distribution with mean 0 and variance 1 for provided like n tends to infinity. That means for large n. Okay, if we have a large number of n and we do not have any information regarding the distribution of the variables, in that case, we may say that the summation of this or the sample mean of these variables follow asymptotically normally distributed. Okay, with 0 mean and 1 variable. Okay, so these are some of the topics that is covered in the 7th week lectures. Okay, now we will discuss about the numericals. Okay, if anyone have any doubts, please ask. Otherwise, we will start for solving questions. Okay. Okay, then the question number 1 is like, if x and y are independent normal variate, independent normal variate possessing a common mean mu. Okay, and probability like this plus this equal to 1 and this plus this equal to 1. We need to calculate the mu and the ratio of the variance of x and y. Okay, we are given some information like first let x, which follows normal distribution with mean mu and variance sigma 1 square, because common mean is mu but variance is not given, so we have considered sigma 1 square, and also y follows normal distribution with mean mu and variance sigma 2 square. Okay, okay, now our aim is to calculate mu. So we have given this property, and we know that when we are dealing with the normal distribution, we first like transform the normal variable into standard normal variable, and then with the help of table we will calculate the probability. Okay, So here, like here first 2x plus 4 variable 4y. Okay, and with the help of linearity property of normal distribution, we will use here like okay, like 2x plus 4y. Okay, this also follows normal distribution actually, but normal distribution with what is its mean? 2 times of x of mean, like 2 times of mu plus 4 times of y of mean. Okay, 4 times of mu. This is the mean for this random variable. And what is its variance? It's 2 square variance of x plus it's 4 square variance of y. This implies like normal distribution with 6 mu and variance is like 4 sigma 1 square and plus 16 sigma 2 square. That means this variable 2x plus 4y follows 6 mu with mean 6 mu and variance 4 sigma 1 square plus 16 sigma 2 square. Okay. In a similar manner, like 3x plus y. Okay, 3x plus y. It also follows normal distribution with mean 3 mu plus mu mean and variance is like 3 square 3 square sigma 1 square plus sigma 2 square, which is equal to like normal distribution of 4 mu and 9 sigma 1 square and plus sigma 2 square. Okay, and also, so this follows this distribution. And also like 2x minus 4y. The third variable is 2x minus 4y. We will use the linearity property of normal distribution actually. Okay. So 2x minus 4y follows normal distribution, which is 2 times of mu plus, sorry, not plus, it's minus. It's minus 4 times of mu. Okay. My, minus 4 times of mu. And variance is like 2 square of variance of x, which is 4 of sigma 1 square. And in case of variance, it is always positive. And 16, 4 square variance of y, that is 16 sigma 2 square. Okay, that is, it follows normal distribution with mean minus of 2 mu and variance is like 4 sigma 1 square plus 16 sigma 2 square. And at last, it is y minus 3x, which is y minus 3x. It follows normal distribution with mean of y mu minus 3 mean of x mu. And variance be like variance of 1 square variance of y, that is sigma 2 square plus 3 square like 9 sigma 1 square. That means normal distribution with minus 2 mu mean and variance be like 9 sigma 1 square plus sigma 2 square. Okay, this is simply, we have four transform variables here. Okay, and we will find these distribution of these transform variables. Okay, and we have found out like these are the transform distribution. Okay, and both are normal with different mean and variance. Here we like 4 sigma 1 square plus 16 sigma 2 square is there. Okay, we may consider for simplicity purpose it is alpha square and 9 sigma 1 square plus sigma 2 square is beta square. Okay, now we standardize this distribution. Okay, like suppose x follows normal with mean mu and variance sigma square, then z, which is a standard normal distribution variant, which is defined as x minus mu upon sigma. and it follows normal 0, 1. Use the similar concept. Okay, so first 2x plus 4y. Okay, now our first condition is 2x plus 4y is less than 100. Sorry, less than 10. Okay, so our condition be like 2x plus 4y. It is probability that 2x plus 4y is less than or equal to 10. 2x plus 4y less than or equal to 10 plus probability that like 3x plus y less than or equal to 9. 3x plus y less than or equal to 9, it is equal to 1. Okay, we just standardize these distribution. So like we may write 2x plus 4y less than or equal to 10. 1 minus probability that 3x plus y less than or equal to 9. Okay, now this quantity can be written as like probability that 3x plus y greater than 9. Okay, because it is like complementary. Okay, complementary. So we can write this equal to this. Okay, now we standardize these variables. So probability that 2x plus 4y minus the 2x plus 4y follows 6 mu with mean 6 mu and variance alpha square, which is equal to 4 sigma 1 square plus 16 sigma 2 square. Okay, so it is 6 mu minus of mu and divided by its standard deviation, which is alpha. Okay, less than or equal to 10 minus 6 mu upon alpha equal to probability like 3x plus y minus 3x plus y follows 4 mu and beta. Okay, minus 4 mu divided by beta is greater than 9 minus 4 mu divided by beta. Okay, it is clear. So for simplicity purpose, we can just take it z1 and 10 minus 6 mu 1 upon alpha equal to like probability of it is suppose z2. Okay, and greater than 9 minus 4 mu upon beta. We can also write this. We can also write this like this. Na? Z2 is less than or equal to minus times of 4 mu upon beta. Is it simple? We can write like this. We have take the negative sign. Okay, so the inequality, the direction of inequality change. Okay, now, okay. Here, I think we do not have to write Z1 and Z2. It's directly we can write Z because this is standardized. No? Then this is like this is standardized, no? And this follows normal 0, 1, and also this. So that means both have the same probability. So this implies after comparing, we have found out that 10 minus 6 mu, not mu 1, it's mu. 6 mu upon alpha, which is equal to minus times of 9 minus 4 mu upon beta. Okay, suppose it is our first equation. Okay, in a similar manner, we can use this relation, this condition which is given. Okay, and okay, let's try. So it is given like 2x minus 4y. Okay, probability that 2x minus 4y, which is less than or equal to 6, plus probability that is y minus 3x is less than or equal to, it's greater than or equal to, greater than or equal to 1, equal to 1. We use the same logic. Okay, so first probability that 2x minus 4y less than or equal to 6 equal to 1 minus probability that y minus 3x, which can be written as like which is equal to like probability that y minus 3x is less than 1. Okay, and then okay, like we will standardize 2x minus 4y minus 2x minus 4y minus 2 mu, and it is also minus 2 mu. It's beta 2 beta square, it's alpha square. Okay, so that is minus or minus plus 2 mu. We'll use minus of minus 2 mu divided by its alpha less than equal to 6 minus minus plus 2 mu divided by alpha less equal to probability that y minus 3x minus y minus 3x, it's also 2 mu actually, and divided by beta less than, we can also use like less than or equal to, because we are dealing with the normal distribution. So a particular, the probability at a particular point is equal to 0. So we may use less than equal to 0 or less than 0. Both are same in case of continuous. So 1 minus minus 2 mu and divided by beta. So again, it is z. It is a standard normal variate. It is z. So that means probability that z is less than 6 plus 2 mu upon alpha equal to probability that z less than or equal to 1 plus 1 plus 2 mu upon beta. Again, comparing these two, 6 plus 2 mu upon alpha equal to like 1 plus 2 mu upon beta. So we have two equations in three variables. Okay, here we have alpha, beta, and mu. Okay, so for solving these, we may divide. Okay, like divide equation 2, sorry, it's 1 by 2. So the equation 1 is like 10 minus 6 mu upon alpha. So it's 10 minus 6 mu upon alpha and divided by it 6 plus 2 mu upon alpha, which is equal to like minus times of 9 minus 4 mu upon beta and divided by 1 plus 2 mu upon beta. So alpha maybe cancel out, beta maybe cancel out. So it comes out to be 10 minus 6 mu upon 6 plus 2 mu, which is equal to 4 mu minus 9. Okay, just change the sign. Then we need to solve this. Okay, so it may be like 10 plus 20 mu. We just multiply this with this. 10 plus 20 mu minus 6 mu and minus of 12 mu square equal to it's 24 mu minus 54 plus 8 mu square and minus 18 mu. Okay, just solve this. After solving, we get a equation, a quadratic equation like 5 mu square minus of 2 mu and minus of 16 equal to 0. Okay. Up to this point, we have a very very smooth procedure. Like we are given x and y variable, which is normally distributed. Okay, we have different transformed variables. Okay, with the help of linearity property, we will solve this. With the help of given condition, we find out two different equations. And now, with the help of these equations, we have a quadratic equation in the mu. Okay, in a function of mu. Now it is a quadratic, so we can solve with the help of like quadratic formula, which is what? Minus of b plus minus root of b square minus 4ac upon 2a. Okay, so mu equal to what? Minus of b, that is 2. Here b equal to this, a equal to this, and c equal to this. Okay, so plus of 2 plus minus root b square. B square is like 4 minus 4 into a into c. So minus minus, here it is minus and c is also minus. So it comes out to be plus 4 into a into c upon 2a. 2 into a, that is 10. So 2 plus minus 20. 324 and divided by 10, which is equal 324 is actually square of 18. That is 2 plus minus 18 divided by 10. So mu have two values. Like if we have considered plus, then it is 2, or if we consider minus, then it is minus of 1.6. Okay, so we have calculated the values of mu. Okay, our next question is like also the ratio of the variance of this. That means we have to evaluate sigma 1 square divided by sigma 2 square. Okay. Okay. So for we have two values of mu. Na? So for mu equal to 2, for mu equal to 2, we use the help of equation number 1, which is this. Mu equal to 2 is 10 minus 12 divided by alpha. Okay. That is 10 minus 12 divided by alpha equal to like 9. Okay, minus times of 9, so 4 mu 4 into 2, that is 8 minus 9. Okay, 8 minus 9 divided by beta. Okay, up to this point. So from here it is like, suppose alpha upon beta equal to actually 2. From here alpha upon beta equal to 2, and the value of alpha is what? The value of alpha is 4 sigma 1 square plus 16 sigma 2 square. That means 4 sigma 1 square plus 16 sigma 2 square. And beta is what? And beta is like 9 sigma 1 square plus sigma 2 square.
Sir, I have a doubt.
Yes.
We take alpha is equal to standard deviation, but 4 sigma 1 square plus 16 sigma square sigma 2 square is variant.
Okay. Wait.
We square the value of alpha and beta, na?
Yes. We must square the value of alpha and beta. That is equal to 4, na? Is it okay?
Yes, sir.
Okay. Now, for simplicity purpose, actually, we have squared this value. Otherwise, we have to take in the value of like 1 by 2, which is quite laborious. Okay. So that means 9 sigma 1 square plus sigma 2 square equal to 4. And from here, so it is like 4 sigma 1 square plus 16 sigma 2 square equal to 36 sigma 1 square plus 4 sigma 2 square. And from here, okay, 16 minus 4, that is 12 sigma 2 square equal to, we have considered this 12 sigma 2 square equal to like 32 sigma 1 square. And from here, sigma 1 square upon sigma 2 square is like 12 upon 32, which is cancel out by 4, 3 upon 8. So sigma 1 square upon sigma 2 square is equal to 3 by 8, which is a ratio in case of mu equal to 2. Okay. In a similar manner, for mu equal to minus of 1.6, we will calculate the with the help of same process. Okay. And we found out sigma 1 is square upon sigma 2 square equal to it's like 87 upon 64. Hope you people may understand this. If anyone have any doubt in this question or any step, please ask. Okay. We have used the linearity property of normal distribution and the standard normal variate property. Okay, and nothing else. Okay. Okay, then next question is like, if x and y are independent gamma variable, it is independent gamma variable with parameter mu and nu. Okay. Then for the variate u equal to x plus y and z equal to this, which one of the following is correct? Okay. So we again now here we will given what, like x follows gamma with mu and mu. Okay, that is it means simple. It means a single. And y follows, let me write it gamma, not c. Gamma mu is one parameter gamma distribution. Okay, and y follows gamma nu. Okay, and we have a transformed equation like what? U equal to x plus y and z equal to x upon x plus y. Okay, so we use the concept of transformation here to find out the to find out like it's a joint distribution and then it's marginal distribution, and then check these are the following. Okay, so first fx is what? It is like 1 upon gamma of mu e to the power minus x and x to the power mu minus 1. And for y variable, it is like 1 upon gamma nu e to the power minus y and y to the power mu minus 1. Okay, like mu is greater than 0, mu is greater than 0, x is greater than 0, y is greater than 0. It is the property of gamma distribution actually. Okay, so now since it is given that it is independent, okay, that means since x and y are independent, it is given. That means the joint PDF of xy equal to the product of x and PDF of product of x and y. This implies 1 upon gamma nu e to the power minus of x plus y and x to the power mu minus 1 and y to the power mu minus 1. Okay. Up to this point, it is okay. Now, we have a joint distribution. Okay. And we need to transform these values. So the transformation equation is like u equal to x plus y and v, not v, it's z. Z equal to x upon x plus y. When we use the transform equation, we will write it in a smaller case. Okay, lower case. Okay, so this from here, like x equal to its uz and y, sorry, z equal to x uz upon u. That is okay, z. It comes out to be z. So with the help of this, u can be written as like what? u like this, and y can be written as like it's uz. It's like u minus of uz, or u1 minus z. Okay, from there, transform equation like this and this. Okay, let me check. Okay, it is correct. Now, our second aim is to find out this Jacobian. Okay, Jacobian. So Jacobian equal to like x upon del u, y upon del u, del x upon, okay, x upon del u, it comes out to be z, x upon z, it comes out to be u, okay, y u, it comes out to be 1 minus z, and z, it's minus of u. From here, it is like minus of zu minus of u plus of zu, which is equal to minus of u. So we have considered the modulus value, which is equal to u. Okay. So our Jacobian is equal to u. Now like our the joint distribution of u and z, it comes out to be like gamma mu gamma nu. Okay, here e to the power minus of x plus y. That means e to the power minus of x plus y. X plus y is equal to actually u. So we can directly like it is u. And y to the power, okay, x to the power mu minus 1 and y to the power nu minus 1. So x can be written like this, mu minus 1. Okay, it's wait, x. We may write at place of x uz. uz to the power mu minus n and y to the power nu minus 1, and y can be written as like u minus uz, or u of 1 minus z to the power nu minus 1. Okay, and multiply by Jacobian, which is equal to u. And now after solving this,
Sir, excuse me, sir. Sir,
yes.
what is the range of this distribution?
Okay, I will solve. Just first write this, and then I will find out its range, the value range of like u and z. Okay. Just actually what like I am using this concept, na? Okay, let me show you. Okay, in case of like this, so we have dealing with the two variables, two transform variables. So this first I will calculate this, then second we will calculate this, and then third we will calculate its range. Okay, so let me finish it first, then I will discuss about its range as well. Sorry. Okay, then u of u or z, it's 1 upon gamma nu e to the power minus u. It's e to the power minus, okay, and u to the power, it's mu plus nu minus 1 plus 1. That is mu plus nu minus 1. Here mu minus 1, here nu minus 1, here u. So mu plus nu minus 2 plus 1, that is mu plus nu minus 1, and z to the power like mu minus 1, and 1 minus z to the power like nu minus 1. Okay. Okay. Up to this point, it is okay. Hello. Okay. Now we will discuss about its range. Okay. What is the value of u and so here x have a range this and y have a range like this. Okay. So from here like it's a mu. Okay. Wait. Okay. Let me check z. Yes. So u equal to x plus y. Okay. So u equal to x plus y. Here it is clearly the range of u is like 0 to infinity. Okay. And the y equal to like u minus uz. From here like y equal to u minus uz. Hello, am I audible or not? Hello.
Yes, sir. Audible, audible.
Yes. Okay. Thank you. Thank you. Okay. That means like y equal to u minus uz. Okay. So we have considered value of u, and here u have also given, and z equal to like x upon x plus y. Okay. So from here like z equal to x upon x plus y, like 1 upon 1 plus y by x. Okay, from here, you may directly see that the value of x and the value of y, you may take any value. So it comes out to be like, it's from like, okay, it's 0, minimum value is, or up to 1. Okay, wait. Okay, so here, suppose we have considered any value of x, then this x and this x is equal, and the value of y is there. So it comes out to be like 0 to 1. Okay, so our final distribution be like uz, uz gamma mu gamma nu e to the power u to the power mu plus mu minus 1 z to the power mu minus 1 1 minus z to the power it's nu minus 1 with this and this. Okay, so our joint distribution is like this. So now we need to find the u follows this distribution. Okay, like u follows gamma mu plus nu. That means we need to calculate, it is a joint distribution, we need to calculate the marginal of u. So g of u, that is okay. So we need to calculate marginal PDF with the help of joint PDF. Okay, we integrate this joint distribution or joint PDF over the range of the other variable. So u, that is z. That means it's 0 to 1, 1 upon gamma mu. It's gamma nu e to the power like minus u to the power mu plus nu minus 1, z to the power mu minus 1, 1 minus z to the power nu minus 1 and dz. Okay. So from here, like it is a, since we are dealing with dz, that means 1 upon gamma nu e to the power minus u to the power nu plus nu minus 1 will be taken outside from the, and it's 0 to 1, z to the power nu minus 1 minus z to the power nu minus 1 dz. This is actually beta distribution. Okay, this is actually beta distribution of first kind. Okay, and the value of this, like okay, let me check. Okay, like integral over 0 to 1 x to the power m minus 1 minus x to the power n minus 1. Okay, this is actually equal to beta mn, and beta mn is defined as like gamma m gamma n upon gamma n plus n. So that means what? That means what? It is like gamma nu e to the power minus u. It's u to the power mu plus nu minus 1 into. It is like beta, it's mu nu. And beta mu can be written as like gamma nu e to the power u to the power mu plus nu minus 1, and this can be evaluated like gamma nu upon gamma of mu plus nu. Okay, so this cancel out, gamma nu will be cancel out. So we will calculate like this: 1 upon gamma of mu plus nu e to the power minus u and u to the power mu plus nu minus 1 for u equal to this. So this is nothing but it is a gamma distribution, single parameter, one parameter gamma distribution with parameter mu plus nu. That means our first option is the correct one. Okay. Is it clear now? Okay. Now we need to like check also, is u and z are independent. For the two variable to be independent, we will check its joint distribution must be equal to its the product of its their marginal distribution. Okay. So we have a joint distribution of u and z, marginal distribution of u. We evaluate the marginal distribution of z. Okay. So it is like now we will consider its u in a similar manner, like it's 0 to infinity 1 upon gamma nu, and then e to the power minus u to the power it's mu plus nu minus 1, and then z to the power mu minus 1 and 1 minus z to the power nu minus 1 du. Okay, now it the integration is over du. That means we have considered z to the power nu minus 1, 1 minus z to the power nu minus 1, and gamma nu will be taken outside, and it comes out to be e to the power minus u to the power nu plus nu minus 1 du. Okay. Okay, up to this point it is okay. Now again this quantity. This quantity is what? If you remember, e to the power minus x to the power n minus 1 dx. This is nothing but gamma n. It is a gamma function actually. Okay, that means z to the power mu minus 1 minus z to the power mu minus 1 upon gamma mu. And this is gamma times of gamma of mu plus mu. Okay, gamma times of mu plus mu. Okay, so this is gamma times of mu plus mu, and this is gamma mu. That is equal to what? 1 upon gamma nu upon gamma mu plus nu. Z to the power mu minus 1 minus z to the power mu minus 1, which is equal to 1 upon beta mu nu. Sorry. And it is z to the power mu minus 1 minus z to the power mu minus 1. This is actually what? This is actually beta distribution of first kind. It is beta distribution of first kind with parameter mu and nu. Okay. First kind, that means its range is from 0 to 1. Second kind, its range is from 0 to infinity. Okay. So now we have the marginal distribution of z and marginal distribution of u. Okay, marginal distribution of u, and we have marginal distribution of z. And you may see, if you check, when you multiply like u of like u into z, this comes out to be like u z of z. That means u and z are independent. Okay, this you may check actually, because just multiply equation double star and equation triple star, you will find out this. Okay, you will find out this. So that means it is independent. So our question will be like, the first one is right, u and z are independent. Second one is right, z follows beta 1, it is also right. That means it is not right. Okay, so our option is option D. Up to this point, any doubt? Okay, now question number 3. Consider a trinomial distribution with the probability.
Please repeat last line.
Okay, wait. Actually, we need to check whether the transformed variable u and z are independent or not. And for independency, the variable, the joint PDF must be equal to the product of their marginal PDF. Okay, so we have a joint PDF of uz. Okay, and we will calculate its marginal PDF. Here, equation double star and equation triple star are marginal PDF of u and z respectively. Okay, then we will multiply double star and triple star. That means marginal PDFs of u and z, and you will, after simplify, you will find out it is equal to this. That means u and z are independent. So our our first option is correct, second option is also correct, third option is also correct. That means the fourth option is not correct, and we will check whether which of the following is not correct. That means option D is the correct one. Okay. Is it okay?
Okay, sir. Okay.
Thank you. Okay. Okay. Now next question is like we are given a trinomial distribution. Okay. And we need to calculate the expected value of y given x equal to 3. Okay. We need conditional distribution because we need to calculate the expected conditional expectation. So for conditional expectation, like again, probability of A given B equal to what? Probability of A intersection B divided probability of B. In a similar manner, probabilities of X given Y. Let me write it in a smaller case. Like distribution of X given Y, which is equal to what? The joint PDF of XY divided by its marginal PDF of Y. So with the help of this, we first calculate the marginal PDF of X, then at X equal to 3, and then with the help of those distribution, we will calculate the expected value of Y. Okay, so first, let's check whether the different values like P1, P2, the probability of success under different conditions. Okay, so, okay, let me first write. Okay, so multinomial distribution. Suppose x1, x2 up to xk are multinomial, then probability that x1 equal to x1, x2 equal to x2 up to xk equal to xk. Okay, so its probability will be like n factorial upon x1 factorial, x2 factorial up to xk factorial, then p1 to the power x1, p2 to the power x2, pk to the power xk. This is the PDF of marginal probability mass function of multinomial distribution. Here the conditions are like this. Okay, like n summation xi, summation xi equal to n and summation pi equal to 1. So with the help of this, just compare these two, the given and the general form. Okay, we will find out like x1 equal to x, x2 equal to y, and x3 equal to what? 7 minus x minus y. Okay, and the corresponding p1 equal to 0.6, p2 equal to 0.2, p3 equal to 0.2. Okay, so up to this point it is clear. Okay, now our next aim is, so we have already like know that na, in this condition like x1 follows binomial n p1. Okay, yes. X2 follows binomial like n p2. So here x1 follows what? We need to calculate the x1 na, because y given x. So we need to calculate the marginal of x. So x1, that is x. It follows binomial n equal to 7 and p1 equal to 0.6. So that means x follows this. So the probability that x equal to n c x p to the power x and 1 minus p, or q you may say, to the power n minus x, x from 0 1 up to 7. Okay, so the marginal PDF of x is calculated like this. It follows binomial with parameter 7 and 0.6. Okay, it follows the binomial distribution actually. Now our second aim is to find the distribution of y given x. Probability y given x equal to x. Okay, so y given x is what? Same formula, x given y, joint divided by marginal. So that means joint. So, y equal to y. Let me write like a general form. And divided by x equal to x. That is, and the general form is here, it is given like this, na? Trinomial 7 factorial upon x factorial, y factorial, 7 minus x minus y factorial. 7 factorial upon x factorial, y factorial, 7 minus x minus y factorial. Okay. And then it is 0 0.6, 0 0.2, 0 0.2. Okay. 0 0.6x, 0 0.2y, 0 0.2, 7 minus x minus y. And divided by this quantity, marginal of x, that is 7cx. So 7 factorial and cx, x factorial, or 7 minus x factorial. Okay, 0 0.6x, 0 0.4, 7 minus x. Okay, just after solving, you may it is cancel out, 7 factorial cancel out, and x factorial cancel out. After simplification, okay, after simplification, we may write like this. Okay, it's 7 minus x factorial, and it's divided by y factorial, and 7 minus x minus y factorial. Okay, and 0 0.6, so the numerator part is like 0 0.2 to the power y, this quantity, and 0 0.2 to the power 7 minus x minus y, this quantity. And in denominator, we have 0 0.4 to the power 7 minus x. Okay. For calculation purpose, we may write like this. Okay. We may multiply 0 0.4 to the power y and also 0 0.4 to the power minus y. Okay. That means it comes out to be 1. We may multiply with the help of this. And then 7 minus x factorial, it's y factorial, it's 7 minus x minus y factorial. The numerator part will be like this, 0 0.2 to the power y and 0 0.4 to the power y. So that means 0 0.2 upon 0 0.4 to the power y. And the rest is like 0 0.2 to the power upon 0 0.4. 7 minus x minus y, 7 minus x minus y. So 7 minus x minus y. Okay, so after simplification, like we will get 7 minus x factorial, y factorial, 7 minus x minus y factorial, and okay, it's 1 by 2 to the power y, it's 1 by 2 to the power 7 minus x minus y. This means what? This is actually y given x. Okay, so this is actually binomial distribution. It is again binomial distribution. So y given x equal to x again follows binomial distribution with n equal to 7 minus x and p equal to half. Okay, now we need to calculate the distribution y given x equal to 3, because we need to calculate the expected value of y given x equal to 3. So y given x equal to 3 is like 7 minus 3, that is 4 factorial, y factorial, that is y, 7 minus x minus y, that is 4 minus y factorial. And it is 1 by 2 to the power y, it is 1 by 2 to the power 7 minus x, that is 4 minus y. It is nothing but binomial distribution with n equal to 4 and p equal to half. Up to this point, it is clear, na? Up to this point, is it okay? Okay. So we have find out that the conditional distribution of y given x equal to 3 follows binomial distribution with parameter 4.5. That means we need to calculate the expected value. And we know that since if x follows binomial NP, then expectation of x is nothing but n into p. So here it is NP. So expected value of y given x equal to 3 is nothing but NP, which is equal to 4 into 1 by 2, which is equal to 2. Okay. Now next question. If the independent random variable x and y are binomially distributed respectively, okay, with n equal to 3, p equal to this, n equal to this, then find the distribution of x plus y. Okay. So here it is given x follows binomial p 1 by 3 and y follows binomial 5 and 1 by 3. Simple it is, na? Because we have already discussed na, additive property of binomial distribution. Okay. So what does it say? It says like you may directly use if x follows this, y follows this, then x plus y follows binomial. Okay. X follows binomial N1P. Y follows binomial.
Sir,
Yes.
answer for question 3.
Yes.
So, okay, thank you.
Okay. Okay. Now in question 4, like we have already discussed, na? Suppose x follows binomial N1P, y follows binomial N2P. Then x plus y follows binomial N1 plus N2P. So this is 8 1 by 3. You may directly use this, or you may use like it's MGF approach. Okay. Here at x follows this, y follows this. That means mxt equal to what? It's q plus p to the power q plus p e to the power t. Okay. It's q plus p e to the power t to the power n. That is 2 by 3 plus 1 by 3 e to the power t to the power n. N here 3. And yt is like 2 by 3 plus 1 by 3 e to the power t to the power 5. It is given, it is independent. So in case of independent, mx plus y of t is mx of t into my of t. Okay. That means 2 plus 3, 2 by 3 plus 1 by 3 to the power 3 plus 5. That is nothing but 2 by 3 plus 1 by 3 e to the power t to the power 8. Now like now uniqueness theorem of MGF says this is nothing but x plus y follows binomial distribution with parameter 8 and 1 by 3. So either you may use the direct additive property of binomial distribution, or you may use the uniqueness MGF approach. Okay. So in both cases, you find out the x plus y follows marginal binomial distribution with parameter 8 and 1 by 3. Okay. Now the next question is like the joint PDF of a random variable xy is given by like this. We need to calculate the distribution of half of x minus y. Okay. That means we are given like the joint PDF is like 1 upon alpha square e to the power minus of x plus y divided by alpha. Okay, so here x greater than equal to 0, y is greater than equal to 0, alpha is also greater than 0. Okay, and we need to find out the distribution of this half of x minus y. Okay, similar like first we are given PDF. We first calculate Jacobian, then its mod, then g of like suppose uv equal to f of xy into Jacobian, and then its range. Okay, these are the 3 steps we are going to follow. First step is like we need to calculate Jacobian. For this, like let u equal to half of x minus y. We need 2 transformation equation here. So we have assumed v equal to like something like y. Okay. This may be taken as x also, but it is taken in such a way that the Jacobian must be not equal to 0. Okay. You may take either x or x plus y or x square, something, whatever you want to ask. You may take, but in this situation, this Jacobian must exist, which is not equal to 0. Okay. So we have considered v equal to y for this purpose. From here, the transformation equation will be like, okay, y equal to v and x equal to like 2u plus v. Okay. 2u or plus v. Okay. Now Jacobian. Again, x u x v y u del y del v del x upon del u, that is 2 del x upon del v 1 y upon u 0 y upon v 1. From here it is comes out to be 2. So Jacobian equal to 2 is given. So our joint PDF of u and v is like 1 by alpha square e to the power minus x plus y. X plus y is 2u plus v divided by alpha. Okay. Simple. And this is 1 upon alpha square e to the power minus of 2 by alpha. It is u plus v. Clear up to this point? Okay. I think
Yes,
it
sir.
is clear. Yes, yes. Thank you. Okay. Then now we need to calculate this part. We need to calculate this part. Now it's about range. Okay. Now for range like this. Here range x, y greater than 0. Okay. It is given like x and y greater than 0. Okay. And u equal to half of x minus y. So x may take value 0 and y may take minus infinity. X may take minus plus infinity, y may take 0. So that means the range of u from minus infinity to infinity from here. And also x equal to 2u plus v. Okay. Hello. Okay, wait. Here x is greater than 0. This means what? Like x equal to it's 2u plus v greater than 0. This implies u is like greater than minus of sorry not u, it's v na v v is greater than minus of 2u. Okay, we have u equal to this, v equal to this. Okay, so we have these two conditions. Okay, now our aim is to calculate what? We need to calculate the distribution of half of x minus y. Here it is also one point also is there, like y equal to v, and y is like what? Y is greater than 0, so v is also greater than 0. So we have a like this kind of, okay, let me write u equal to 1 by alpha square e to the power minus of 2 by alpha, it is u plus v. I have missed one thing actually. We need to multiply with the Jacobian here also, which is twice, and it comes out to be like this. 2 by alpha square e to the power minus 2 by alpha u plus this. Okay, and both are, and everything is okay. Now this is, and the range of this like this, u v is greater than 0 and v is greater than minus of 2u. Okay, so this is our joint PDF of uv. Now we need to calculate the distribution of half of x minus y, which is the u. That means we need to calculate the, so we've considered v, it's 2 by alpha square e to the power minus 2 by alpha u v dv. So the range of v is, now here there is some tricks or some like, let me draw. Okay, see here v equal to 0. Suppose it is v, it is u. Let me check. Okay, there is one more page actually. So let me draw. Okay. Okay. So it is here u is minus infinity to plus infinity. Okay. So it is like u and it is like v. Okay, y-axis is like v-axis. So our range is v equal to 0. V equal to 0, that is this point, u-axis. And then v is greater than minus 2u. V equal to minus 2u is like this. Okay. So v equal to minus of 2u. This line. Now we need to integrate this in these two ranges. The first one will be like this, and second one is like this. Okay, suppose it is first one, it is the second one. Okay, in first region, the range of v is what? From this point to this point, and this is actually v equal to infinity, and this is v equal to minus 2u. Okay, and here v equal to 0 and here v equal to infinity. So up to this point, that is u is less than 0, the range of v is minus 2u to infinity. And when we have considered u is greater than 0, the v equal to the range of v taken as from 0 to infinity. Is it clear or not? Because we may like partition this into, like we have two cases, two different cases. Okay, for u is greater than and for u is less than. Okay. If anyone have any doubt, please ask. Okay. So this is our marginal PDF of u. Okay. So okay, then like we may calculate for two different values. Okay. So like this. Okay, let me. So for first reason. For first reason, suppose for first reason, the range of v is minus 2u to infinity. And the PDF is like 2 upon alpha square e to the power minus 2 upon alpha, and okay, it's u comma v. It's u plus v na, exactly. U plus v. Okay, so it's u plus v dv. That means we have 2 upon alpha square e to the power like minus 2u by alpha. So it is minus 2u to infinity e to the power minus 2 alpha by v dv. So it is 2 upon alpha square e to the power minus 2u by alpha, and then e to the power minus 2 alpha into v divided by minus 2 by alpha minus 2u to infinity. So from here it is like 2 upon alpha square e to the power minus 2u by alpha, and here minus 2 upon alpha is there, so 2 to 2, like 2 will be cancel out and 1 alpha is cancel out, so we may directly write like it's 1 by alpha. Okay, and e to the power this, then e to the power minus 2 by alpha into infinity, which comes out to be minus infinity, which comes out to be 0, and plus e to the power minus 2 alpha minus 2 alpha into minus 2 mu. That comes out to be like okay. Okay. So it is 1 upon alpha e to the power minus 2u by alpha. This comes out to be 0, and e to the power like 4u by alpha. So it's 2u by alpha, it's 4u by alpha. So it's 1 by alpha e to the power like 2u by alpha, for u is less than 0. Okay, for u is less than 0, we have got the PDF of u is like this. Okay, now for second reason. For second reason, it is like from 0 to infinity, the same from 0 to infinity, 2 upon alpha square. It's e to the power minus 2 alpha u plus v dv. Okay, so we have got the same result actually. So it's 2 upon alpha square e to the power minus 2u by alpha, and it comes out to be like minus 2 by alpha v divided by minus 2 by alpha, and it is from 0 to infinity, and then it comes out to be 1 by alpha e to the power minus 2u by alpha, and then again we have considered it 0, then e to the power minus 0, that is 0, not minus 0 actually, e to the power 0, and minus minus it comes out to be plus e to the power minus infinity. So it comes out to be 1 by alpha e to the power minus 2u by alpha for second reason. Okay, for u is greater than 0. Now you may see 1 by alpha e to the power 2u by alpha, 1 by alpha e to the power minus 2u by alpha. That means the distribution of u is like 1 by alpha e to the power minus 2 by alpha or mod u. Okay, for u like this. Okay. Anyone have any doubt? Okay, then now next question is like we are given if f x1 and x2 are independent uniform variate on 0, 1. Then we need to calculate the distribution of x1, x2. Okay. Okay, then again, suppose f of x1 is like 1 for x1 this, f of x2 equal to 1 for this. Okay, and it is independent. That is the joint PDF of x1, x2 is also 1. Okay, now we need to transform this we have a transform variable like this. So consider like again u equal to x1, x2, and for simplicity purpose we take v equal to x2. Okay, so the transform equation will be like small u equal to x1, x2, and v equal to like x2. From here x2 equal to v and x1 equal to like u by v. Okay, now the next step is to calculate Jacobian. So Jacobian is like this again. X1 u, x1 v. It's x2 u, it's x2 v, which is equal to what? X1 with u, that is 1 by v. X1 with v, so that is minus of u by v square. X2 u 0, x2 v 1. So it is 1 by v. Okay, our Jacobian is 1 by v. Okay, now the joint PDF is so the joint PDF of u v equal to like 1 into 1 by v. The joint PDF of x1, x2 is 1, and the Jacobian is 1 by v. So it comes out to be direct it's 1 by v for u. Okay, now the range of u and v. Okay, the range of u and v is like here x2 equal to v, so both have the same range. So x2 lies between 0 to 1. This implies v is like between 0 to 1, and here x1 equal to u by v. x1 lies between 0 to 1. This implies that it's u by v. This implies v. Okay. So the range of u is like from 0 to v, and the range of v will be like from 0 to 1. Okay. So this is our joint PDF of u and v. Now our aim is to calculate the PDF of x1, x2. That means u. That means the PDF of u. So v, it's uv pv. So the range of v. Okay. So we may in jointly we may like write this na. So the range of v is like the range of v is like u to 1. The range of v is like u to 1, and it is 1 by v dv, which is equal to the, it is nothing but like log of v, na? Log of v from u to 1, which is equal to log of 1 minus log of u. So it's gu of u equal to of u for u lies between 0 to 1. Clear up to this point? Na? Okay. Now next question is like the average age of college students in a country is 25 years. Okay. So we are given like average age, that is mu. Mu is given as 25 years. And standard deviation like sigma is given as 9.5 years. A simple random sample of size 125 students are drawn. What is the probability that the sample mean age of the student is greater than 26 years? Okay, so again, we are given like mean and variance and n. So here we use the central limit theorem. Okay, we are given mean variance and the average mean, that is x bar. So here, like CLT say, like it's x bar minus mu upon sigma upon root 10. It for sorry, normal 0 1. That means what? Okay. X, this follows 0 1. That means probability that x bar is greater than 26 years. That is probability that x bar minus mu upon 9.5 divided by root n. Sorry. Is greater than 26 minus 25 divided by 9.5 divided by 125. So probability that it comes out to be z greater than it is around 1.18 after calculation. The numerator part is 1 and the denominator part is something which is less than 1. So it is about approximately 1.18. Okay, after solving. So that means we need to calculate the probability that z is greater than or equal to this. Now again, just draw it is standard normal z equal to 0. We need to calculate z is greater than 1.18. Suppose it is approximately 1.18. So greater than this means we need to calculate this property. So this property is calculated like this, na? This is probability that 0 to infinity minus probability that 0 to 1.18. So it is 0.5 minus it is pi of 1.18. And with the help of normal table, you will find out the value of this is like 0.3810. 0.3810. So the probability that x bar is greater than 26 is nothing but 0.1190. Okay, simple probability question. Now the next question is like, if random variable x and y are IID, normal, 0 sigma square, then what is the distribution of u equal to this? Okay. Also, it is a suppose x follows normal, mu sigma square. Okay. Then z, which is equal to x minus mu upon sigma, it follows normal 0, 1. And then z square, which is equal to x minus mu upon sigma whole square, it follows chi square with 1 degree of freedom. Okay, so this is the property how chi square variate is defined. Chi square is nothing but the square of the standard normal variate. So here, okay, it is given like x follows normal 0 sigma square, y follows normal 0 sigma square. Okay, so that means x minus 0 upon sigma follows chi square 1 degree of freedom. In a similar manner, y minus 0 upon sigma follows chi square degree of freedom 1. Okay, now xi follows chi square with ni degree of freedom. Then summation of xi follows chi square summation of ni degree of freedom. Okay, this is also the property of chi square. Okay, so from here, additive property. Okay, from here we may write this now. So like x minus 0 upon sigma whole square plus y minus 0 upon sigma whole square. This follows chi square 1 plus 1, which is 2 degree of freedom. So it is nothing but x square plus y square upon sigma square sigma square. That is, it follows chi square 2 degree of freedom. That means the distribution u, which is equal to x square plus y square upon sigma square, follows chi square with 2 degree of freedom. Okay. Now the next question is like, again, it is a question of transformation. If random variable x and y as IID normal 0, 1 distribution, then what is the distribution of u by u, which is equal to x by y? Okay. Okay. Here x follows normal and y also follows normal. So that means fx is equal to 1 upon under root 2 pi sigma equal to 1. That means it's e to the power minus 1 by 2. That is x square by 2. Similarly, fy is also like 1 upon under root 2 pi e to the power minus of y square by 2. And similarly, x is greater than like x from minus infinity to plus infinity, y from minus infinity to plus infinity. It is given, it is IID, that means independent and identically distributed. That means we have the joint PDF like this, which is equal to 1 upon 2 pi e to the power minus 1 by 2 x square plus y square. Okay. For x belongs to minus infinity to infinity, y belongs to minus infinity to infinity. Okay. So this is our joint PDF. Now we have a transformation equation. So let u equal to x by y, and again v equal to y. So small u equal to small x upon small y, v equal to y. From here, like y equal to v, and x equal to like it's uv. Okay. Now the next step is to calculate the Jacobian. Xu, xv, it's yu, it's yv, which is xu. That is v, u, it is 0, it is 1. So v. So we have taken the mod, like a mod object. Okay. So our joint distribution will be like this. U. Okay. So it is 1 upon 2 pi e to the power minus 1 by 2. It is x square plus y square. Okay. So x square, that is u square v square plus y square is v square. Okay. Into v. Okay. This is the case actually. Now here we may like simplify it like this: 1 upon 2 pi e to the power minus 1 by 2 v square u square plus 1 mod of v. Okay, so it is positive term and v square is also positive. Okay, just keep in mind. So we have a joint distribution. Now we need to calculate u, x by y, which is u. So the marginal of u, which is equal to, we have considered the range of v, which is minus infinity to infinity. Okay, here u and v have the same range because y u here, like y have a range of minus infinity to plus infinity, so we have also minus infinity to plus infinity. Okay. And u also have u equal to x upon y, so it also comes out to be minus infinity to plus infinity actually. So minus infinity to plus infinity. Okay. Now u, and then we may write like this: 1 upon 2 pi e to the power minus 1 by 2 v square, it's u square plus 1, and it is mod v dv. Here, since v square is a positive, okay, and mod v also gives, always give a positive quantity, that means it is a kind of a even function, and the integration of even function, that means we may write like this, na? 1 upon 2 pi, okay, and then it's 2 times of minus infinity to plus infinity will be now 0 to infinity. It's e to the power minus 1 by 2 v square, it's u square plus 1 dv. Okay, now let or put, it's 1 by 2, it's v square u square plus 1 equal to t. So from here it comes out to be v dv equal to dt upon 1 plus u square. Okay, so So 2 cancel out. It's 1 upon pi, and it is 0 to infinity e to the power minus t and dt upon 1 plus u square. Okay, and this comes out to be like it's 1 upon pi 1 plus u square. It's e to the power minus t minus 1 from 0 to infinity. This comes out to be like 1 upon pi 1 plus u square 1 minus 0, that is the same quantity. That means the u is like 1 upon pi 1 upon 1 plus u square for u equal to this. This is actually nothing but the Cauchy distribution. Okay, standard Cauchy distribution is parameter 1 and 0. Okay, so we have calculated the PDF of x by y when x and y are IID normal 0, 1. Like in a similar manner, we can solve this here, like with the help of additive property actually. Okay, here it is clearly like x1 follows exponential lambda, x2 follows exponential lambda, then x1 plus x2 follows gamma. We need to check, na? Okay, let's like x1 follows this, then m of x1 t is what? M of x1 t is like 1 plus t upon lambda to the power minus 1. Similarly, m of x2 t is 1 plus t upon lambda to the power minus 1. Okay, and these are independent. These are independent. That means m of x1 plus x2t will be written as m of x1t into m of x2t. That is 1 plus t upon lambda to the power minus 1 into 1 minus t to the power lambda to minus 1. That is, it comes out to be minus 2. This is the, with the help of the existence and uniqueness property of MGF, it is the PDF of gamma distribution.
Excuse me, sir.
Yes, yes.
The MFT of exponential distribution is 1 minus t to the power.
Yes. Oh, I think I told 1 minus, but written plus. It is 1 minus. Na? Okay, thank you. It is 1 minus t upon lambda, 1 minus, and this. Okay. So it is nothing but x1 plus x2 follows gamma distribution, and it is gamma distribution with parameter what? It is parameter like k here 2, so 2, and it is lambda. It is the additive property of exponential distribution as well. We have already discussed in the previous slide. So this is this. That means the first is right. Okay, the first is right. The second one is, it is beta n1 p1 binomial, and it is binomial n2 p2. So x1 plus x2 follows this. So it is not right, because for binomial distribution we have already discussed, na? Like x1 follows binomial n1p and x2 follows binomial n2p. In that case, x1 plus x2 follows binomial n1 plus n2p. Okay, here the probability of success must be equal. Then it is follow. That means the second one is not follow, but third one is the same one, the additive property of the binomial distribution. And at last, the fourth one is also. So x1 follows this, x2 follows this, then x1 plus x2 follows this, which is not possible because in the previous we have already discussed. Okay, so we have first and third is the correct one. So option B is the right one. Okay. Anyone have any doubt till now? Or if he or she want to ask any question up to this point? You may answer. Anyone? Okay, then I think we should stop here then. Okay. Let me first stop the recording.